Our next session features two coworkers. One is a longtime friend of the symposium, and the other is making his debut appearance. Scott, too, serves as Vice President of Sustainability, and he's also the co-founder of the Center for Energy Efficiency and Sustainability at Trane Technologies. In addition, he leads the Center for Healthy and Efficient Spaces. He's also responsible for climate and energy-related public policy matters. Basically, Scott is a busy guy. Now, Vijay Desmukh is a member of the residential business leadership team, also at Trane Technologies. Since joining Trane in 2014, he has held roles in the commercial HVAC business and the enterprise team. Now, in his current role, Vijay focuses on driving customer-led innovation and go-to-market strategies. He holds an MBA from Purdue University and an MS in mechanical engineering from Colorado State University. So he's able to combine the business and the technical very, very well. Now, this discussion is going to be moderated by Greenbuilder Media CEO Sarah Gutterman.
Well, hello, Scott and VJ. Thank you so much for being here. I'm thrilled to have this conversation. I know we are going to cover a lot of very interesting information. So we're here to talk about the ClimateTech evolution, and let's first start with thermal management in buildings and system-wide operations. So Scott, I think this is a question for you. Decarbonizing the built environment will require better thermal management and system-wide optimization. What does that even mean? And how should we be thinking about these concepts across entire communities, campuses, districts, and cities? What is the shift from isolated upgrades to system-wide thermal strategies look like?
Yeah, hi, Sarah, and thanks for having us. We're delighted to be a sponsor of another sustainability symposium. It's great to be a partner of Greenbuilder. We think that you lead the way in terms of helping the built environment understand what's possible, and thanks for all that you do there. So we're happy to be here today, Vijay and I. And thanks for the question, too, about how we view thermal management. You used a term that there's probably not a better description for what we're attempting to do now. And it is a step back, though, because Trane Technologies is a company that really has doubled down on the concept of decarbonization. And the question is, what can be done for the built environment related to decarbonizing it? I mean, transportation went before us. The energy sector has been decarbonizing. We've seen huge changes and transitions over to renewable energy. The transportation sector has been working on transitioning to EVs, as we know worldwide. The built environment is the great big opportunity for us now, as you and all of the participants in this symposium understands. And so Trane Technologies as a company took a step back a few years ago to say, what is really possible in decarbonizing buildings? And to your point and how you asked the question, you understand that the history of cooling and providing comfort for buildings was really to focus on components of a system. We focused on the components within a heating system. We focused on the components within a cooling system. And we tried to make every one of those components efficient and better than the last generation. We've sort of wiped that thinking off of our whiteboard, and we have developed a new way of thinking about decarbonizing as well as providing comfort. And what I mean by that is, what if there was a way to think of managing the thermal dynamics within a building as a system, meaning you move heat around where heat's needed to make a space cooler. And then for the warm areas, you cool those areas and the heat moves somewhere else. And you manage the thermal dynamics of a system. And that requires more than just focusing on components. It requires us to think much more holistically about how the building is controlled with building automation. It requires us to think differently about heating and cooling. In the past, we installed two systems, a heating system and a cooling system. They run parallel, sometimes at the same time. It was not the most efficient way to do it. And that was the incumbent way of doing this. So it's almost heresy to say that we have come up with a new way and a new approach, but we have. We now have single combined systems. They're heat pumps, but they're smarter heat pumps than what our parents or previous generations knew, because now we know that you can't just have a heat pump and say we're through. Now we have to combine that with automation, really smart sensors And we also have to combine it with other things like renewable energy sources that can be on site or can be from a local grid. All of those things have to be thought through well in advance of the application of the system. But once it's done, we're seeing a huge step change in the outcomes of the building performance, which is another thing we've been doing much better at. And some of your participants will understand how a building performs today versus how it was designed is really important to understand. We want high performance today and tomorrow. And to do that, we're going to need buildings that have building automation, that have better sensors, that have included things like digital technologies. All of these dots, the decarbonization umbrella under that is the digital technologies. We've not left out the core of our equipment, but we're connecting all those dots in very different ways. And it's actually an exciting time because of what we're seeing. Some of these buildings that we've applied this new way of applying systems to have seen a 400% increase in their efficiency. They now come with, in some buildings in Europe, come with free cooling because the system can do both in buildings that may not have had cooling in the past. And the same works throughout the Americas as well. So it's an exciting time. You can have the efficiencies, we can decarbonize, and we don't have the negative trade-offs.
It's fascinating, Scott. And VJ, I promise I'm coming to you with some more questions, but first I want to ask Scott a follow-up question. Scott, as you know, and we've talked about, I am really keeping my eye on phase change materials.
Oh, yeah.
And this concept of buildings as batteries, so to speak. So phase change materials are often called thermal batteries of materials. So tell us about phase change materials. What is the benefit? What are they? What are their benefits? What are the biggest misconceptions? How close are we to seeing them in mainstream construction? And how do they fit into the broader ecosystem of building products and materials and systems?
Well, I think we're at a great spot to talk about this, but also to apply it, Sarah. This technologies have been around for a while, but now's our moment. I think we see more and more people understanding the value of these phase change materials. Thermal storage is what Trane Technologies calls it, but phase change is really what it is. The concept itself is rather simple. It's almost embarrassingly simple. If I can quickly explain it to your audience, the way we apply it. I mean, essentially, we have large tanks that create ice while energy prices are lower and the grid itself is not as busy. Think at night when we're all sleeping. These tanks are creating large volumes of ice, a car size, minivan size cubes of ice. And when the energy prices are higher and people are pulling on the energy grid increasingly throughout the day, at that point, we begin melting the ice, thus the phase change. And as the ice melts, obviously it creates a cooling air flow and air vapor, which can then be moved into the building and can be dehumidified, go throughout the building and provide cooling at a much more efficient way of dynamics within the system, but it also at a time when the grid needs it most. So this is all about resiliency on the supply side of the grid. It's also about making a building perform better than we've been able to in the past. So these things are co-located within the building or maybe outside the building. And its time has come. They're more affordable than ever. I mean, there have been some myths. One of the big myths was these things are too expensive. That's no longer the case. The ROI on these systems being added to an upgrade of a comfort system in a building, in a commercial building, now the ROI payback period is rather quick. The other big myth was complexities. For whatever reason, in the past, there was misconceptions about these things are too complex. We are all making ice in our homes every night. And so we know that these things can happen. We just scale it up significantly, bring it into the building, and we know how to dehumidify spaces. So these things can be done. We have to dispel of the myths first, cost and complexity. And I think we're going to see a much greater adoption. We've actually seen a gigantic acceleration over the last few years with these being placed inside buildings and district cooling applications as well. But I think we're just at the tip of the iceberg. Pardon my pun. I think I think the runway is really long for this. We need this now more than ever because the supply side is I think, increasingly under more demand than we expected maybe 5 years ago, given some drain on the supply side via AI and other needs from data centers. And so I think that these phase change materials, these applications on thermal storage, this may be the perfect moment for these to truly and be rapidly adopted.
Again, fascinating. Thank you, Scott. And when you explain phase change materials in the context of the thermodynamics of water, I think people really understand that.
I hope so.
And, we understand what happens there. So, hello, VJ. How are you?
Nice to meet you, Sarah. Thank you for having me. It's a pleasure to be here.
Thank you so much. I would love to hear your perspective on circularity and circular products in particular. So, fully circular products, they sound amazing, but how do we move from one-off innovations, an economy-wide shift? What is needed to make products that are designed for disassembly as the new standard? And then kind of second of that question is, what are some standout examples of truly circular products or materials that are already disrupting the industry that you have your eye on?
No, it's a great question. I think we have to look at also the context and the perspective. Right? So if you're thinking about home construction or even commercial building construction, it's a very complicated process. Right? You have a lot of different technology choices. You got a long supply chain at times, a lot of different products that get used to create that built environment. And if you think about impact from a sustainability standpoint going into the future, like new construction is relatively a smaller portion of the market if you think about occupied homes or occupied buildings. So I think from our perspective, when we think about circularity, it's about making sure that your design specifications and what you select for choices is done right up front, because now you're going to have decades of impact going forward. Right? So when you think about new construction, that has probably the largest impact going forward. And making sure the specifications are as open as possible, that allows for choices from a sustainability standpoint. I think that's probably the best place that we can influence. And I think that's been one of our lessons learned is when we think about us as a company and how we're designing new products, right? When we have revisited and examined our own processes and how we pick materials, and from a circularity perspective, we've kind of overhauled that whole process to make sure that we're making smarter choices on how we design and build products going into the future. A few examples I can share is we've been very successful looking at adding green steel to our products in terms of sheet metal that we use in our products. We look at recycled aluminum as another example. If we think about HVAC, steel, aluminum, copper are probably the biggest ingredients of what we use in our products. And that content in terms of recycled content or raw materials that are produced at lower energy consumption, right? I think that percentage keeps going. So I'd say those would be a perfect example from our standpoint on where that we are seeing that positive impact.
Interesting. And BJ, let me follow up with another question for you. When we talk about kind of next level waste and resource management, what does that actually look like in practice? Are there technologies or systems today that either Trane is creating or that you just see in general in the industry that are truly making homes and buildings self-sufficient? And, along those same lines, a lot of these technologies promise long-term savings, but may come with higher upfront costs. So how do we make these innovations more accessible, not just to early adopters, but to everyday homeowners and renters and builders and developers?
No, it's a great combined question there. Maybe I'll segment into two different pieces here. One is the purchase choice up front. And I think that's where HVAC can be very expensive for a lot of people. And it's a choice people have to make, not that they want to make. So I think from a purchase standpoint, there are a lot of different options from an HVAC standpoint, where from an entry-level system to, if you go and purchase more efficiency upgrades, you can save almost 20% energy. And even though the product is expensive, there are a lot of options available. There's a tax credit option available that's called 25C. There are local rebates available from utilities. There are sometimes state rebates available. Sometimes we carry promotions as well, seasonal promotions as a company as well. So leveraging those at the moment of purchase and making sure when you think about upfront costs versus energy costs, you're making the right choice and a balance. Because energy cost, HVAC, is almost 40% plus of total energy consumption per house. Now, if you're able to drop that by 20% by going after energy upgrades in what products you're selecting, that can have a significant impact on the sustainability standpoint without compromising comfort. In fact, if you go with the upgraded option, it actually enhances the comfort in terms of how energy gets managed inside of the house. So I'd say those probably would be the two areas. And I think the third thing that's growing is also the recycling aspect. I think we as a company are also focused around reclaiming refrigerant, reclaiming some of the waste materials, and even our own factories on how much waste we put out to landfill. So we have zero waste to landfill mindset in our company. Most of our facilities comply. But if you apply that even in the construction process, I think the same logic applies over there as well. So I think there are different dimensions on how we think about circularity and overall sustainability impact from homes.
Thank you. Scott, let me come back to you. Now, let's talk about acceleration and urgency, because we're really not talking about just tweaking systems anymore or making marginal changes. We're talking about reinvention and making radical changes. And it's one of the reasons why we love working with Trane and working specifically, Scott and BJ, with you, is because you're always thinking about that big picture and you're really always leading the charge with respect to innovation with sustainability in mind. And that is special and rare, and accolades and call out to you. So thank you for that. So Scott, what are some of the top climate innovations that will define the next, say, 5 to 10 years, and what's holding them back from scaling faster?
So thanks for the compliment, Sarah, about Trane Technologies. I think one of the things that we've done is that we challenge ourselves, and one of the ways we challenged ourselves is we've set a really high bar for ourselves with our Gigaton Challenge. Some of your participants may have heard about it. That's our commitment to reduce our customers' emissions by 1 billion. That's a gigaton of greenhouse gas emissions by 2030. We're at the midpoint this year. It's been a huge learning curve for us as a company, this commitment, because we take it very seriously. Our progress on this commitment winds itself into all the business, all the areas of the business that you would think that it should be, to make sure that we hit it, because it requires us to innovate differently. It requires us to challenge ourselves on, to your question, what is next generation? How far can we go? How deep can we go on making equipment more efficient, helping consumers understand what's possible, maybe transitioning ahead of even the industry on some things like refrigerants. And the Gigaton Challenge, we're using it for all the reasons we envisioned from the beginning, to challenge us in all those areas. And it's working. And to your point, it helps us accelerate these ideas, these innovations, how we go to market possibly differently. Vijay can talk more deeply about how we apply heat pumps and our thoughts there. But one of the examples where Gigaton has been refrigerant transitions. We have exceeded not only just the legal regulations, but we've been the first in industry to transition to next generation refrigerants, and the latest refrigerants, which are an important part of emissions reductions. And we have to focus on those. You know, we're so much better now than we were just a few years ago, even earlier this decade, in terms of the impact on the environment from this generation of refrigerants. And but we're not happy now. We're already researching and developing what the next transition will look like, how the equipment should be configured to make that happen. So the teams are really working. And then I've already spoken about this whole systems level energy efficiency. Systems level energy efficiency in the future will be focused on using digital and AI to help us tweak systems in ways that we couldn't do that before now. And when I say tweak systems, I mean, some of these tweaks lead to significant efficiency gains. I've heard 20 to 30% efficiency gains just by integrating some AI technologies that help the systems that are in the building run more efficiently. They also send signals back to us to understand how the equipment's performing. The great thing about that is the service techs who are out in people's homes, the service techs who are rolling in vans to commercial buildings, before they arrive, they already know what the priorities are for making the system run more efficiently and to operate better. So there's no wasted time when they arrive. They already have great insights. We know which parts they should have with them. They know what tweaks to make. So the digital tools, we're just scratching the surface on how these will help us make buildings, homes, commercial buildings perform more efficiently and be high performing buildings across the board. We now can see that greater things are possible though. And I think that's what's so exciting.
That's fascinating. Vijay, I'd like to get your perspective on this as well. What are some of the top climate innovations that you have your eye on? And then kind of as a second layer to that question, what role should building professionals, product manufacturers, and even consumers alike play in accelerating the adoption of breakthrough climate tech, especially when the risks of not acting are growing so quickly?
I think I love what you said at the end, is there are so many choices available today, right? There's no reason not to act. It's really a wide landscape on choices. So I'd say from a technology standpoint, what's exciting right now is the industry has gone through this major transition, at least for residential HVAC and some like commercial applications are adopting towards greener refrigerant than what we've been using in new equipment. So the next gen refrigerant that we're using now, right now, they have 78% less carbon footprint impact on the environment than the refrigerant we used to use. Along with that, we've also improved our overall energy efficiency for our products as well. Our portfolio is 4% more energy efficient than 6 months ago. So it's along with the environmental impact from the refrigerant, looking at making sure you're selecting the right high efficiency equipment. That's the second one. Third thing is heat pump. Heat pumps are a phenomenal product from a sustainability standpoint. You're not creating heat, you're transferring heat. And it's the same product that's doing it. Heat pump acts as an air conditioner in summer. It acts as a heat pump transferring heat in a reverse fashion in winter. Right. So now you have a much simpler system for an HVAC product standpoint that does both things equally well. And heat pumps, what people remember is, well, heat pumps of the old, where they were predominantly used in the south, and they had probably less technology than what we have today, and they would not keep up with the colder climate. Now, heat pumps as a technology, they're operating minus 15, minus 20 degree Fahrenheit, and they can keep you as comfortable, sometimes more comfortable, and faster comfort than even a furnace. So that's exciting. I think digital is another exciting space. Scott covered it already. Is what we see as an example is the scaling up of digital technology. Once you give customers choices of and information on how they're using energy, they start making immediately smart choices. So when you look at next gen systems that we are offering and what's widely available in the market as well, is smarter thermostats, right? Smart metering products on water usage and so on. I think that's a great opportunity. And lastly, I think Scott covered it from an energy storage standpoint or thermal storage standpoint, is also looking at holistic energy management for the home. Right? You have to look at homes in a holistic manner. And that gets to your last question around what are things people need to be aware of. I'd say a holistic long-term perspective and also educating yourself on the choices. Today, there's no reason why you cannot have more comfort and more energy efficiency, but with a long-term view to make the right purchase choices. There's plenty of options, and it's a whole new world out there.
That's wonderful. Thank you so much. I have one final question for both of you, but before I go there, I want to just ask a question that came in through the Q&A from our good friend, Jack Armstrong. Hello, Jack. Thank you for asking these questions. And I'm going to compress both of your questions into one. And Vijay, maybe this should be directed to you. Jack is wondering first if you have or are going to implement take-back programs. And also, Jack heard that recently at the Builder Show in Vegas, there were some comments from heat pump skeptics about the service life of heat pumps, which they say is less than previously thought. So can you comment on both of those things quickly?
Can I answer the first one on take back first, Sarah?
Yes, please, Scott.
Then Vijay can pick up the second one. The take back. So we're very close to announcing a take back program. We've been remanufacturing components of our systems on the commercial side for many years, decades actually. We're working on a program that will extend that and expand that program. And we're working on a demonstration pilot program on product take back. We'd be the first in the industry to do a full take back, like Jack mentioned in his comments, of like other industries. It's very complicated, as you can imagine, but we're working with some suppliers and partners and some facilities. And we're going to try that both on the residential and the commercial side. and to have a great team focused on that. More on that to come later this year, though.
That is very exciting. Can't wait to learn more. And thank you also for working on that. Vijay, what would you say to the second part of the question about the kind of the life cycle of heat pumps?
Yeah, I think life cycle is also a function of maturity in the technology. And I think what people are probably remembering is when heat pumps were probably used in more strenuous application, like climate-wise in the past, when probably they were not designed to handle that kind of a load, like cold climates, for example. So heat pump of the old, if you think about climate zones like, let's say, Dallas or Minneapolis or New York or Portland, right? They're different climates. The requirements are different. And in the past, right, when you think about heat pumps, how they were designed, they're not designed for all of these climates. So when the heat pumps didn't last long, part of the story is the reason why. They were probably not used in the right setting. But if you think about heat pumps of today, like you have to first of all take into account what climate zone is the homeowner living in. Like what is the right heat pump to select? There's a lot of different technology that's gone into the next gen heat pumps. Variable speed technology, inverter technology is a good example of that. Where now you're optimizing your HVAC system life performance is not optimized because it's varying the speed and it's not seeing as much security duty cycle. It's not on or off. You're operating at variable speed. So that's one. Second one is a component technology that goes in. And in AC and a heat pump, the big difference is the components that go into these products. There's a lot of new technology that's gone into these components and how these products are designed to last longer than the heat pumps of the old. So that's kind of the secret sauce around what's new and exciting about these next-gen heat pumps. And again, it comes down to making sure you're selecting the right system for the home and for that particular climate. And once you do that, then there will not be any adverse impact in terms of the life cycle of that product. And I think that especially when you combine digital aspects of it, right, we have systems that can allow you not just to manage energy from a homeowner perspective remotely, but the dealers that install those systems, they can monitor your system remotely as well. Now think about that from a life cycle perspective, preventive maintenance perspective. There's a lot of new technology out there that can prolong the life of that product for the duration that the homeowner is going to be in their house.
Wonderful. Thank you so much. Well, Scott and Vijay, we have reached our time limit, although I wish we had more time because you are fascinating and I have at least 8 more questions for you. However, that will have to wait perhaps till next year. Thank you so much again for your leadership and sustainability. Thank you for your generous support year after year for our Sustainability Symposium. You enable us to bring this free event to our audience and, with some of the most relevant topics. So Scott and Vijay, again, thank you so much for being here.
Thank you, Sarah.
Thank you.